This conference will now be recorded.
Good afternoon, everyone. I'm Maurice McHugh with the GOZAR program. I would like to make some announcements before we get started. Please remember the book club today is being recorded. Please mute your microphone and turn off your webcam. Just want to remind you that the Q&A section will be right after the presentation. And I strongly encourage attendees to post their questions in the chat room. The questions will be fielded through there. If you're logged in under an alias or a different account, please sign in with your full name or specify your full name when asking a question in the chat. And we're always looking for future presenters. Please feel free to contact the TARS team if you're interested in participating. And Tristan has just posted the link to the facilitator and presenter form in the chat. The training team can help create training materials that may be unavailable otherwise. Please contact Ross Van Til for information or questions on that. Before we get started, I just want to say a big thank you to OCLO and both the GEO and LEO programs, and especially to our facilitator today, Chris Smith. So let me introduce our presenters today. Amy Stevermer has extensive involvement in Earth system sciences education and training, and currently helps coordinate efforts for NOAA's environmental satellite training projects at the COMET Program at UCAR. She brings an atmospheric sciences and technical communications background to her work and projects aimed at helping effectively use water, weather, and climate products and information. Patrick Dills has been a meteorologist and scientist with the COMET Program in Boulder, Colorado for 30 years. In his role, Patrick provides guidance and satellite remote sensing expertise to COMET, online lessons and courses that focus on satellite capabilities and applications for operational forecasters, as well as for other interested users and learners. Amy and Patrick, welcome to the book club, and please take it away from here. Thank you.
All right, thanks for that introduction, Maurice. I think we are ready to go. We have a good presentation for you today on some satellite products and applications for marine meteorology and then ocean surface lessons that are fairly new on COMET. So we'll take you through a view of those and maybe leave you with some other things to explore following our talk. Next slide, please. COMET's environmental satellite training projects are supported by NOAA's GOZAR and JPSS programs, and we develop our training in collaboration with a lot of people out there. A significant number of people involved from the National Weather Service and NOAA NESDIS, great collaboration with folks at SIMS at the University of Wisconsin, CIRA at Colorado State University, NASA Sport, and GINA. And then we have subject matter experts and product developers who work with us from various parts of the US as well as internationally, and we are very grateful for all those collaborations. The training we produce, next slide, please. The training we produce is freely accessible online at MedEd. All you need to do is register an account using your email address and set up a password. Right now, we provide access to over 1,000 lessons. Many of them are in languages other than English, and you can see the full list of topics there on the right. Next slide, please. So we wanted to give you a chance to explore a little bit and get familiar with MedEd and how to find things there. So I think our facilitators, yes, there's a link in the chat. Go ahead and click on it. And then on the left side of the screen, you should be able to see options to filter the lessons by language and by topic. So what we'd like to have you do is look for satellite meteorology lessons in English, and then just type in the chat the letter that represents how many you find. So A, B, C, or D. or the closest number to what you might find. Okay, hopefully people were able to get to MedEd. So this is kind of a trick question. We actually have 153 English language satellite lessons on MedEd. We had a new lesson on satellite products for volcanic ash published just yesterday. So that might also be one that might interest some of you. Can we go to the next slide? So in addition to using those filters to search for lessons, there's also a text entry box at the top of the screen, and you can search title words, which are different from keywords. But a lot of the lessons we're showing you today, we're showing you the title as well as the URL. So hopefully that will help with finding things after our call today. And I think that is what I have. I'm going to turn it over to my colleague Patrick now, who will take you on a deeper exploration of some of these lessons.
Good morning, good afternoon, or in whatever time zone you're in. Thank you for that introduction, Amy. And let's start our tour. Let's call it a boat tour in the SS Comet of 4 different lessons recently published, or say in the last year, in the last couple of months. Let's start our tour in the Great Lakes. And this particular lesson is titled Satellite Applications for Marine Fog, and we're really interested in looking at fog in this lesson over the Great Lakes, fog formation. As many of you probably know, springtime, even early summer, the Great Lakes are ripe for fog conditions, given lakes are still relatively cold, partially ice covered. Here we have an event from March in 2022. And what we wanted to do is cover a period, say roughly 24 to 48 hours, where we can anticipate the pre-fog environment, or assess the pre-fog environment, look at fog formation and fog evolution from the satellite perspective, obviously. And we do make references to what forecast offices in that region, what NWP is indicating, but really our focus is on let's see what products we can bring to bear and fit most accordingly within that context. So we have RGBs, we have some NuCap soundings, we have the Gozar probability, IFR, LIFR probability product, some SST, and ALPW moisture product. Next slide, please. Thank you. So there are 3 different parts to this particular lesson. As I mentioned, assessing pre-fog environment, and there we were focusing on primarily looking at some sounding, moisture data, looking at the synoptic setup. And here, this slide is just a highlight of the second part to this case exercise, where we are on the lookout for initial fog formation. We've already made our assessment where we think it's more likely. We're covering the Great Lakes as a whole, so it is a rather large area, but we've identified some of those conditions in part 1. And so what we do with our interactions here is we start off by saying, well, I've got a slew of products, satellite products. Which do you, learner, think are most appropriate, say, for initial fog detection? So we go through that first part in the exercise, and then the second part of the exercise, you can see that 4-panel image in the middle, is to show products. And there are more products that can be selected in this view, and they can be looped and they can be synchronized. And in the image on the right, ask the learner now, well, outline some areas where you see initial fog formation taking place. And obviously you have to see the loop to really appreciate where and when that is happening. And all of this is followed up with feedback. And so there are opportunities for the learner to go back and say, oh, okay, I'd like to try this again. So, and the third part, which I'm really not showing here, is once the fog has formed and we've identified some of those regions, we continue to look at products and emphasize product selection for monitoring that fog evolution into the overnight hours and the early morning hours. Okay, next slide, please. Let's get back in our boat and let's warm up a little bit because it's been cold for a lot of folks. Let's go to the tropical Pacific, where we have another lesson here where we're emphasizing RGB imagery for interpreting kind of typical convective type of weather south of the equator and north of the equator. So one event that we cover, Samoan Islands region in August, and then North Pacific, August through September. So the first event, Samoan Islands, is cool seas and convection. We have some interaction between surface trough and easterly trade wind disturbance. And the second case, we have a kind of an MCS development where there's interaction, more interaction between upper level and surface features. And again, we bring here, the emphasis is on RGB products. So we bring a set of RG products to evaluate. And let's step into the next slide. So what we like to do is really present a forecast challenge or forecast problem. And in this case, over the Samoan Islands, we're interested in this interaction between the surface trough and easterly wave, the convection that fires up. And let's go on to the next slide, please. Thank you. So what's typical in many of these case exercises, at least the ones that I'm highlighting here, is we'd like to start off maybe looking at upper level features. And so what we're doing here, this is actually I'm going to go ahead here and look at the North Pacific case along the date line. Is this interaction between an upper level trough, call it a TUT, if you will, and surface trough and a little bit of an easterly surge. And we're beginning to see an area of clustering of convection. And so the first part of the challenge, again, is to identify those upper level features. And we have drawing tools, drop and drag tools to help do that. We interleave this with feedback. And then we transition to actually looking at cloud features themselves. What can we say about, in this particular example, is the convection? Which RGBs are giving us type of information that we're interested in terms of intensification or persistence of the convection? Is it short-lived or does it fail to mature? And then weakening or decay. And so again, this is a multi-part multi-question exercise that goes through this cloud identification with an emphasis on convection. Next slide, please. Okay, now we move northward. It's still warm, even though it's November 2020, and we're looking at a focus here on the impacts of strong winds and heavy rainfall and forecasting that potential. And this is over the Guam and Mariana Islands region, but can really apply across the Pacific. Particularly interesting case, we work with Brandon Adelet out there in Guam. And we follow this case. We start 3 days in advance, looking at, again, the interaction of synoptic features. It's kind of a blend here, again, of mid-latitude, upper-level features and surface features. And some of the strong convection that resulted as a consequence of that interaction is, we'll see in a moment, led to really some severe convection and severe thunderstorm warnings, which are typically rare for that region to be issued. And so again, we start out with a batch of products, not just emphasis on RGBs here. We're looking at microwave, visible infrared, scatterometer, winds. And next slide, please. So what we see in this early period, 3 days out, is a focus on kind of the larger picture. Can we analyze some of the upper level and low level features that come into play so that we can begin to track those, which we may be doing already. So then 2 days out, we want to build more confidence in that forecast, reassess some of those same features, or maybe there's something new that's coming into play. And then once we get to 1 day out, we're beginning to focus more on the convection, looking at the potential of what could be some of the strongest winds that we're seeing with some of the outflow regions of this convection. So we focus more on, say, scatterometer and AMSR2 winds, and then looking at some of the microwave rainfall rate products as well. And again, these are all staged with multiple tools that allow for interaction, for drawing, and so forth. Next slide, please. Okay, and once we get to the actual event, we're zooming in more on the region now of the Mariana Islands and Guam specifically, with a radar or an X-rad overlay indicating the range. So what we're actually looking at now is the convection that's approaching. We ask them specific questions about where do you see the strongest convection? Where do you anticipate some of the strong outflow winds? Can scatterometry give us some indication of how strong those winds might be? Once the convection comes into radar range, then we have have obviously additional information. On the right, you can also see there's an hourly blended rainfall rate product that we can look at to help us maybe get a handle of how strong some of the rainfall could be. So a very interesting case. We bring it into where the event actually unfolds. Okay, let's move on to the next case then. And the fourth and final case. Now we're moving northward into more of the, let's see, I'm going to skip this particular slide. Let's go on to the next slide. And we're going to be looking at a typhoon extratropical transition and re-intensification case that actually moved from west of the dateline into the Bering Sea and brought some really severe wind and storm surge flooding to the west coast of Alaska. And this happened in September 2022, somewhat unusual in the sense that they don't typically anticipate events like this until later, say, into the fall. So again, similar to previous cases, we start out 3 days ahead of the event. We'd like to look at some of the features, synoptic features that are interacting with this Typhoon Merbok to help us anticipate extratropical transition and the potential. In this case, really the key is, could we see re-intensification, which really had implications then for the Bering and Western Alaska. So next slide, please. Okay, and we'll move through this a little bit more quickly. So what you see here is we talk about a little about the uncertainty in terms of intensity and model track 3 days out. We start by identifying features. You can see that in the lower right. We ask them very specifically, identify short waves and PV anomalies. So the interaction here is what we call a delayed feedback approach. So we ask the learner to select a particular product, to identify that feature we're interested in. So we already know ahead of time what are some of the features that we need to focus on for extratropical transition. So we allow them to do the drawing, do their analysis, and then come back, and they need to select what the most likely outcome is based on their analysis and the forecast reasoning that goes along with that. So we give them then some feedback where they interact with the MIC or the lead forecaster, say, well, I agree with you, I don't agree with you for these reasons, maybe go back and try again. So that's kind of how this delayed feedback approach works. Next slide, please. So this here, we're actually going through transition. We're trying to forecast the re-intensification or the potential for that. And so we continue to track those same features that we identified in part one, I'm sorry. Next slide, please. And then we finish up with now the storm has undergone transition. It is in the bearing. It is beginning to re-intensify, and we'd really like to focus on the wind field. And what are the tools to help us with that? And we focus here on primarily the scatterometer winds. We have great coverage at these higher latitudes, better refresh rate. And what we'd like to know is what is our confidence in the scatterometer winds. And this is important for assessing some of the NWP guidance. Where and how strong are the winds for assessing that potential wind damage and coastal storm surge? So we have 4 products there along the top. We have a nighttime microphysics RGB, air mass, long wave IR, blended microwave rainfall rate. And if you'd like to pick one, please enter that into your chat window, A, B, C, or D. Obviously, we can't really interact with the data at this point, but what we're asking is what product could help us identify where scatterometry may be biased in some way. Or you could just do it as a thought exercise. I see a D. Yeah, D is pretty good. When we're looking at scatterometer winds, we know that rainfall can bias the wind speeds toward the high end. So rainfall, say moderate to heavy rainfall rates, is something we would look at. Now, as a proxy, we could say, oh, I can use the nighttime microphysics RGB because it indicates convection. And maybe where I have some deeper convection, I can anticipate rainfall. So I should watch out for that area. In this case, there was some bias maybe indicated on the northwestern side of the storm, the southeastern side of the storm. We didn't really have any rainfall, and scatterometry indicated somewhat stronger winds, a stronger wind field than what we had in the NWP. So this was important guidance then for the forecaster. Okay, I think that wraps it up for me. Let's take a look at the next slide.
I'll pick it up from here. We're going to go from the atmosphere down to the ocean surface now, and we have just a couple lessons we want to share with you. The first one is the satellite remote sensing capabilities for ocean color. So this is a nice overview lesson. It's pretty short, maybe about 20 minutes long. It centers on 4 videos that demonstrate satellite capabilities for these 4 topics you see: dissolved organic and inorganic matter in sediments, oil spills, sargassum, phytoplankton, and ocean productivity. And you can see some of the imagery in there. These videos are neat. They have a lot of pretty imagery, a lot of focus on LEO products for this. So we've got short information about current satellite capabilities for this topic area, and then a little bit of a preview of upcoming missions to come. So that is there. Next slide, please. And then if you would like a deeper dive into one of those topics, we have a full lesson on monitoring harmful algal blooms and sargassum. This one uses some real event examples. You can see the locations and 3 dates there, and highlights some of the products that are useful in detecting the presence of harmful algal blooms or sargassum, as well as how things might evolve. And so you can see 3 of the indices used to measure those values there, and you can practice with these in the lesson. There's some questions that learners can go through to actually provide some decision support based on what they see in the products. Next slide, please. Most of the lessons we've shown you today, as well as lessons on many other topics that you see here, are bundled in what we call distance learning courses at COMET. So if you follow that link, you can see the whole listing of case exercises in these various topic areas. And most of the ones we're showing today are in that marine applications area. So this is a good link to have for reference. Next slide, please. Here are basically just the thumbnails, the title images for the 6 lessons we showed today. And we can go to the next slide. We will leave you with the MedEd website link, 1,000 freely accessible lessons there. And then here is my contact information as well as Patrick's. And Chris, I think we turn it over to you. Hopefully we have some time for questions. Thank you everyone for your attention today.
Yes, thank you, Amy and Pat. I now do encourage attendees to stay on for discussion, including those from field forecast offices and the regional headquarters. And I encourage you to turn your cameras to active cameras if you can. Please submit questions. You can either do them in the chat or ask verbally in the chat room. And a week from today, on Thursday, January 30th at 12 p.m. Eastern, we will have Kyle Hilburn from CIRA and Scott Lindstrom from SIMS to discuss Gremlin in National Weather Service operations in the Pacific region. Also to note, next week is we will be transitioning the Satellite Book Club to Google Meet, so no longer on GoTo after this week. You can check out the mailer next week for a link to the meeting. If you have any questions, you can contact the Tower S team, Kashal Bowman or Emily Maddox, for questions about the Satellite Book Club or for configuration of satellite products. And now I will start with some questions. I did have a question. How do you accept input for what training should be developed? It seemed like there was a big push for maritime applications, which I'm certainly happy for working with the Ocean Prediction Center, but I was curious kind of how that chain of events goes.
Starts by talking with people like you, Chris, Yes, we talk with forecasters in the Weather Service. We try to get input from SUs. We try to get input from stakeholders, both in the US, a lot of times internationally. We have reached out to broadcasters, university faculty, to sort of gather information about training needs. And then we work with our GOZAR and JPSS sponsors to sort of prioritize the topics. Sometimes we'll go back, we'll have a survey, we'll have people rank things. But you are correct, there was a lot of information that came in around the end of 2023 for addressing offshore maritime types of applications. And so, through 2024, we've been able to publish a lot of things that address those in a lot of different regions over the ocean or large bodies of water.
All right, thank you. It looks like we do have a question from Scott Lindstrom in the chat. What kind of feedback does COMET get as far as the lesson length goes? Is it still shorter is better?
I would say it varies. We're often asked for more. And so when we do longer lessons, as Patrick showed, they're often, they're broken up into, you're looking at different time intervals, and then there's different forecast challenges. So you can always piece things out. But we are also trying to do a lot of shorter training, come in, do a forecast challenge, maybe looking at just 2 or 3 different products instead of a whole suite of integrated products. So we're trying to do both. Yeah, that's a great question.
All right, thank you for that answer. Do you have any sneak peeks into any more marine trainings that are being developed? Are there any on the way? I know there's one about fog and warm marine environments. Can we have any sneak peek into those?
Patrick, are you, I think I might turn this over to a third COMET person to speak more on. Yes, we have a COMET lesson coming on fog in the marine environment. It uses a case from Tampa Bay and then Key West. And so just looking at how those processes are different, I think that's going to about wrap up what I can think about for marine, except that we have some other work at COMET that we've been doing with the Pacific International Desk. And there's a lot of effort to bring some satellite products into that training. I personally know less about the specifics of that training.
What I could add, Chris, is just briefly, and this is not really, hasn't yet been kicked off, but we are planning a short lesson on equatorial waves. And so where exactly that's going to be focused, I don't know yet, and or what the timeline, but this is something that we'll be developing this year.
Very interesting. It looks like Leanne came on camera. Do you have anything to say, Leanne?
Hi, good morning, everyone. Thanks, Chris. Yeah, I think just maybe expanding a little bit on what Amy was saying about some of these upcoming marine projects for the Pacific. And those are for the Pacific International Desk. They're going to be fairly short lessons as well, focusing on some features we can identify from satellite imagery that perhaps we can't see in the NWP, in particular cold core upper air lows that can come in and cause some fairly severe weather over the Hawaiian Islands and surrounding areas. That's one of the lessons. That one's getting pretty close to being finished, and a second one will be about the tropical convergence zone, South Pacific convergence zone, and some of the weather that can come with that. So there's a focus on the satellite element because that's the data set that is easily available. They're going to be short lessons, just a couple of minutes. We're trying to integrate some video feedback instead of text feedback in that. So you actually have a verbal debriefing and some analysis on the screen for people to see sort of what areas you're looking at. So it's a little bit more visual, but short and to the point. So those two should be out in the next couple of weeks. I'd say easily, or hopefully by the end of February, you'll get to see some of that. The Caribbean fog example that Amy was speaking about as well, exactly right. It's about following the different thresholds for fog development in the Tampa Bay port area versus Florida Keys, and what some of those aspects are that we can see on satellite imagery, where some of the limitations are. And it's a real focus on satellite. There's not really bringing in a lot of NWP data or anything like that. It's about how can you use your satellite image to really complement what else is around you. So those ones are all in the mixer at the moment and looking good.
Thank you for that context, Leanne. I know I did see some dense fog advisories in Florida this week, so I think it's pretty fitting that's being developed. And it looks like Sheldon in the chat passed a link to the Sierra-advected layer precipitable water product and how that can be used for cyclogenesis and bomb cyclones. He has some examples from November in the North Pacific. I know we were looking at those at the Ocean Prediction Center, so thank you, Sheldon, for passing those along. And it looks like we do have a question and a hand raised from Bill Schoberg. Bill, if you want to ask your question.
Yeah, it's not a question per se, but I'd be happy to talk with anyone who has a training need if we can get it into the satellite world. We would either Goes and Leo would become advocates and maybe pay for that training. So contacting the offices directly is not a bad thing either. So.
All right, thank you, Bill. I'll hang on for a couple more minutes for any other questions. I did have one more myself. I know not exactly GOES, but when new satellites come on, like Meteosat third generation, that might have some applicability to GeoXO or things like that. Do you work on any trainings outside of just GOES for the geostationary satellites? Or what's your course of action there?
Was that a question for me?
For any of the COMET folks, I suppose.
Okay.
Waiting to see if anyone else wanted to chime in. So we do have a training collaboration with UMETSAT. I think the point you just made about GeoXO in the planning now and things from the Meteosat new generation, there's things there, and there's things from KMA and other groups that are going to be relevant to things coming like from GeoXO. And so we are working with those. I would say I don't know of anything specific right now. I feel like a lot of that is probably down the line. Patrick, do you want to chime in?
Yeah, I think back to GOES-R, and we started several years before that, because GOES-R was really a revolution in terms of the capabilities that we were anticipating. And so we were able to use some proxy information from AHI, from Himawari, to help us in that sense. But it was more of an overview initially of the different applications and environmental topics that we could address. So we started, and as we got to the Himawari launch, which came before GOES-R, we could build in some examples. What the thing that comes to mind is that when we use that third generation is the hyperspectral sounder. And so I think there's going to be an opportunity to communicate finally what it will bring to the Americas, that capability. And so I think that's going to be, we will have a lightning imager and enhanced ocean, I believe, ocean color, so atmospheric composition and aerosols and so forth. So there are numerous opportunities perhaps to even use capabilities that have already been launched to help us preview GeoXL.
All right, thank you. I don't see any other questions in the chat or any hands raised, so I will pass it back to our hosts now to wrap it up for today's book club.
Thank you, Chris. Amy and Patrick, thank you very much for presenting at the Satellite Book Club today. And thank you again, Chris, for your excellent facilitation during the discussion today. As Chris previously mentioned, please remember in a week from today, Kyle Hilburn from Sierra and Scott Lindstrom from SIMS will discuss Gremlin for NWS Ops in the Pacific region. And this will end the meeting today. Thank you all and hope to see you next time.